You said you wanted to, yeah.
Yeah. Maybe if you just want to start by introducing yourself and introducing SwitchPoint and whatever you want to say.
Yeah, happy to do so. Well, my name is Ray Guzman. I'm the CEO of SwitchPoint Ventures. We are an AI venture studio, which basically means we look for opportunities to use AI to improve a process, a workflow, et cetera, that we think has broad commercial applicability. That will typically start with a conversation with somebody in the industry that may mention something they're struggling with. And we will start to then call on our contacts to kind of validate that it's a pervasive issue and it's not an N of one, right? We don't want to build something that only one customer in the world would need.
Mhm.
But once we figure that out, Brady, what we do is we'll build it with that initial partner and kind of validate, that our models work and the solutions creating value, et cetera. And then as a studio, what we'll do is we'll spin that company out or that product out into and create a company. And then at that point, we go get investors to capitalize the company. So we could hire a management team for that new co, et cetera. And their job is to go scale it. So as a very practical example, I had a friend that about 5 years ago started complaining about physician recruiting. Um, and the following day, I happened to have lunch with another friend who brought up clinician recruiting as a pain point. And so at that point, I'd been in healthcare nearly 20 years, had never thought once about physician recruiting. And all of a sudden, 2 days in a row, I'm hearing kind of the same thing. And so we started calling on different, in my case, health systems, different healthcare leaders, typically C-level folks about the scope of the problem and validating that it was a real issue. And then we actually went and built something that we thought was a very different approach to getting at the clinician recruiting problem. That company is called Winnow. It's 18 months old as a company. It's doing very well. It's already got 10 major health systems as customers, very large ones. Just probably all the folks that popped into your head are on the
Mhm.
platform. And to give you an example of how machines are very very useful for something like this. As a general rule, when you survey clinicians who switch jobs, why'd you leave this hospital to go work for that hospital, et cetera, 90% of them will attribute their willingness or at least openness to that conversation to someone they personally knew.
Mhm.
So, well, I wasn't thinking about changing jobs, but Brady told me about this wonderful opportunity where he works. And so I at least listened to the conversation. And so if we know that to be true, can you start to use machines to help you understand that? And so, for example, what Winnow does, and this is kind of where the AI really comes in, we've done a few things. We've aggregated a data set, some public, some proprietary, over that encompasses about a 17-year history of all the job changes of folks with an NPI number, which is almost every doctor in the country has an NPI number. If you build
Mhm.
insurance, you have an NPI number. It's a national provider identifier. And so we use that as kind of our ground truth to understand how big is the universe, right? How many doctors and actually mid levels, so NPs, PAs, CRNAs, and doctors all have an NPI number. So how big is the universe? And so because there's a finite number of people, that lets us really focus on getting a deeper understanding of who these people are. And because we have so much of the data is public, where they go to school, residency, fellowship, where have they practiced, et cetera. And because we've got so much history of it, roughly 17 years in most instances, um, we have a read on where have they been, what um, if we assume that their career path or the places where they've chosen to practice tell us what their preferences are from a geographic perspective, that's super insightful, right? If we see that somebody's done the New York, Boston, you know, Philly tour, they may not be willing to move to Etowah, Tennessee, right? They might, but possible, not probable, right? Well, the machine actually understands kind of this concept of sister cities. So that's one thing that the solution does. Another thing that it does, Brady, is it starts to look at changes over time and just starts to understand, what the average, I don't know, nephrologist stays enrolled 6.5 years. The average nephrologist at this career stage, maybe it's 5 years, et cetera. And so it'll start to understand the likelihood. So Brady's been a nephrologist for 4.5 years at this career stage at this organization. If he's going to switch jobs, he's probably thinking about it right now, right? So we don't know that for certain, but again, this becomes probabilistic, and certainly no harm in at least trying to have a conversation with you. The worst you can do is say no. Where it gets really interesting is, and there's a lot more under the covers here, and you can ask me questions as we go. The last mile though is once we identify the folks that would be likely willing to practice at your organization and location, and once we identify the folks that are likely thinking about a change, that results in kind of a list of prospective candidates. And then what we do is we take that list and we map all the relationships with your own providers. And then we can tell you, so if Dr. Smith is near the top of that list for all the reasons I mentioned, and then more, we'll know, well, Dr. Lowry actually knows him. Why don't we have Dr. Lowry help us connect with Dr. Smith and see if he or she's willing to have a conversation with us.
Yeah.
So there are about 1,200 variables per clinician in our data set. So you can imagine the kind of modeling that's happening here. And then when you think about each of those kind of pillars that I just mentioned, some of our customers started asking really good questions like, hey, if you could tell me who to pick off from another health system, could you point the models inward and tell me who my flight risks are? Right. So I can slow down my recruiting challenges if I had a better retention. So again, just another way of the same data cut a little different way, focus inward instead of outward. But all of these things are just predictive, and it's an example of how we're using AI to disrupt the clinical recruiting space.
Yeah,
so hopefully awesome. I gave you kind of the theory. I gave you the theory kind of what a venture studio does, but I wanted to kind of give you a real story to hopefully crystallize it.
Yeah, that's awesome. So you guys have worked with physician recruiting and retention. What are some other areas you've worked in?
Yeah, great question. We've done a lot. So I didn't really talk a lot about SwitchPoint. I just told you what we do. We've been together the company's been around for about 5 years. The team goes back about 12 years to a predecessor company that we built and ended up exiting in 2017. So I'll tell you that's a story there that might be interesting, and then I'll delve into some of the other things that we've done at SwitchPoint. Without boring you to death, I will just tell you we were doing a lot of quality work in the hospital space, and we had a particular customer who was a very large publicly traded health system, and they were doing exceptionally well on quality, and they had one particular area that they were hyper focused on, sepsis, and they were actually doing very well in sepsis relative to their peer group, relative to kind of where the market is, right? So they were significantly outperforming their peers, but they had a mantra, and that mantra was one is too many. And so from their perspective, sure, we have a very few number of cases relative to our size and scale, but because of our size and scale, that's still a lot of people. And so one is too many. And so we kind of decided, hey, what if we could become predictive of that and help inform earlier where sepsis might, be an issue that's not been identified yet. So what we ended up building through the course of a number of iterations was a platform that at the point of admission to a hospital would get, this might be more technical than you want, but we would get what's called an ADT feed. I think every modern EMR has an ADT feed. It's an admit, discharge, and transfer feed. So it just means when somebody's being admitted, transferred, or discharged, it's the HL7 transaction that gets sent to communicate across different systems. We just got a copy of the ADT feed. So at the point of admission, we'd know, pretty near time, typically within a minute or less, who was being admitted, and the machine would score it. We're talking like a second or less, often sub-second response times. And it would then produce a score. And if we didn't think there was any issue with Brady, the machine would stay silent. In the event that the machine saw a risk for that given patient of having sepsis, we would alert the care team immediately. And there, in the first instance, it was through like a secure communication platform, like basically like a secure pager almost. And it would just simply say the patient's the last I think it was the first four initials of the name and maybe like the last four of the social. And um, I think we had the social in there by the time it was all said and done. But it would just say suspect sepsis. And we were not diagnosing patients. We were not doing anything like that. It was just decision support. But what it would often lead to is Dr. Lowry would get that alert and just kind of go, I didn't think about, this particular, but now that I think about it, UTI, a little confused. Yeah, potentially let's it would just cause the clinician to at least stop for a moment. If you can think about how hectic an ED is, to just stop for a minute and contemplate whether that particular patient may or may not be dealing with a sepsis issue. We were deploying into many hospitals, eventually multiple health systems, and that ultimately that platform is ultimately what got our company acquired. But we were, on average in the mid 90s in terms of if we said suspect sepsis, um, people started to understand that they should really pay attention because the machine was right and overwhelmingly, high number percentage of the time. Maybe worth noting, one of the issues in the space is, and I'm sure you're going through sensitivity and specificity and AUC and ROC and kind of all these various metrics. Just to put it in layman's terms, like you wanted the machine to catch as many cases as possible, but not be tuned to alert in areas where it was clear. So in other words, we didn't want a lot of false positives out there, and so there was always tension on managing. So we knew, would you miss a case or two because the models were tight? Possibly, but we also knew from a behavioral perspective, if we were throwing a bunch of alerts and let's say the machine was right half the time, human tendency is to start to be dismissive of those alerts, and all of a sudden you lose kind of the effectiveness or the power of the alert because people are, it's a coin toss if it's correct. So that's another kind of use case. That was a very clinically oriented use case where we used AI and built a pretty cool platform that like I said, got us an exit in 2017. Another AI solution that we've got in market, it's a company called Polaris. If you read, anything medicine related, you're hearing about nurse shortages, physician shortages, different specialties have pretty significant shortages. You look at something like urology over the next 5 years, we're going to have some pretty big shortages here, which is concerning for a whole host of reasons. And so what we have found, and this was through work with, again, same story. We had a particular customer who we asked a question of in the course of doing a bunch of work with them about how they schedule their teams. And they eventually explained they don't really give it that much thought. It's just, frankly, can you get a warm body into a shift, right? It's an appropriate shift. And so we backed into what we were calling a high performing teams model, where what caused us to ask the question was we were seeing certain pairings. In this case, this was an anesthesia company. And so you had, anesthesiologists and CRNAs, and sorry, something's bugging my eye here. And so if you could imagine, one anesthesiologist may work with 15 different CRNAs over the course of a week. And so you kind of have to take a step back and look at it at a macro level to kind of see these patterns, if you will. But we started noticing that for whatever reason, when Brady and Ray are paired together, exceptional outcomes from a quality perspective and a patient sat perspective. But maybe when Brady and Cannon work together, they have exceptional outcomes. But for some reason, when Ray and Cannon work together, not so great, right? No patient, like nobody's at risk or anything like that, but just means not performing nearly as high as you and I would or you and Cannon would, right? So there's something about that pairing. That's what kind of got us down this path. And so when we started investigating how they scheduled, what became apparent to everyone was in their particular model, and we have I'm going to be a little generic about the results just because this is public info about who the development partner was. And so I don't want to divulge. But let's just say when you looked at the number of hours of labor they paid for versus the number of hours that had offsetting revenue, there was a significant gap. Let's call it almost 50% delta. And so if you could think about that from a waste perspective, so you think about it one of two ways. Either they had more capacity, and as a result, could schedule more procedures. Or you could argue they were overstaffed and just didn't know it because they couldn't efficiently uh, staff to the demand. And so that last comment right there, staffing to the demand, ended up being the big kind of unlock, as they say these days, which is it turns out most health systems, we haven't really found anybody doing it well. They don't have enough visibility 8 weeks out to anticipate how much demand is going to walk kind of through, come through the hospital, if you will, or hospital based. So it's good because we find ourselves in ED, OR, med surge, and then like the hospital based things like anesthesiology, as an example. And so if you knew 8 weeks out what your demand was likely to be, if you could imagine a kind of a demand curve projection, then you could more tightly put your supply curve or your labor pool into it. And so rather than have that waste that I was talking about with that first kind of client we dealt, all of a sudden you're more efficiently scheduling your resources. And so the net result of that, it turns out, is maybe you're not understaffed. Maybe you're properly staffed, or maybe you're overstaffed relative to that. So the findings kind of vary by customer, frankly, even within a customer, by hospital. But I will tell you, on average, we find that most people are scheduling about 20% more hours than they need to. And the reason that becomes important is, one, it removes some stress from the schedules, right? You're not kind of wearing people out because you're over scheduling, because you don't have enough visibility. The second thing, though, is what we find is a lot of these health systems and hospitals, that last 20%, that last mile, if you will, that they're over scheduling, they don't have the staff, and so they're going out to the agency or locums market, and they're paying 3, 4, 5x for that labor that frankly they didn't need. They just don't. They can't see out far enough to realize they don't need it. And so we've got customers. We have a hospital, for example, as part of a pretty major health system that's south of Nashville, over in Alabama. Their data, not ours. They're claiming a 19-to-1 ROI, but it's because that last mile, turned out that last mile for them was agency and locums, where they were paying a huge premium. And once they got right sized on the demand curve, they realized they didn't need all that temporary labor, and so the savings was pretty enormous. So what we're doing there is we're training the machine based on history, based on all sorts of variables that you might expect, weather, outside events. So if you know that there's a concert that comes every year at the same time, if you know Bonnaroo's coming every year, and you know when that is, and the machine knows that, does that have an impact on the demand that you might expect at your facility? We know, for example, we did this analysis once for a health system in West Tennessee. ED volume spike. Is there a relationship between temperature and ED volumes? And in this particular health system's case, the answer was yes. And it turned out the magic number was 98 degrees for them. Once it got above 98 or higher, which makes sense, right? You have a bunch of heat related casualties, if you will. Yeah. And then the inverse, right? When it's super cold, the opposite. And so the question wasn't, we know anecdotally, but the question they wanted to answer was, how should we be thinking about this? Is there a cut point where the data is pretty clear? And so that way, if we know that it's going to be 98 degrees tomorrow, we might have a few people on standby ready to come in if we start seeing a surge. So if you know all these things, if you can imagine the machine having this kind of knowledge and having, again, thousands of kind of variables that it can consider, then predicting 8 weeks out, I don't want to trivialize it. That was hard. It was one of the harder things we've ever done. I mean, we've built literally hundreds of solutions over the years. This one's a bit AI and a bit operations research, or OR. So you don't normally see those two things together. You're seeing more of it now. That's still kind of a new space of the intersection of those two things. But all of a sudden, you've empowered these health systems to be more efficient. And the reason that matters is not just coverage and burnout and all these other things, but typically where the shortages are most pronounced in rural parts of the country, where we need those resources the most. So it's probably not terribly hard. It might be competitive, but it's probably not terribly hard to recruit a nurse to Nashville. It's city, people want to be here. There's so much to offer. Not to pick on Etowah, but since I picked Etowah earlier, I'd say it's probably harder to get somebody to want to move to Etowah, Tennessee. Which, by the way, I've been there a few times. Beautiful place. Like, I'm not knocking it, but it's not quite the draw that Nashville is, right?
Yeah.
So, those were two more examples. I mean, if
Yeah.
you want, we can keep going. Is this helpful? Is this what you're looking for?
Yeah, that's very helpful. Man, I could use some of that AI for I'm actually gonna be the lifeguard manager this summer at the pool. So I'm trying to like manage a staff for the first time, like hire the right
Cool.
amount of people because I don't want too many, so get enough hours and yeah, it's really cool stuff
Well,
you're doing.
let's talk about that for a minute. That sounds like unrelated, but it's actually related. So I'll give you so to do that, uh, for a light, like if you said, "Hey, could I use Polaris for, the lifeguard scenario you just gave?" No, but here's why. It's unless I'm wrong about this, the machine's training on, um, the history of the health system or the hospital, right? Depending on who we're working with. And so we have start and stop times in the ED. We have, unique patient identifiers. We know what the staffing ratios are. Sometimes in certain states are regulatory. So like, you might find, for example, California, it's a 4-to-1 requirement. So no matter how optimal the machine might produce an outcome, if it's in California, we have a forcing function that says get as optimal as you can within the constraint of there being a 4-to-1 ratio, right? So as an example, so like sometimes when people hear AI and prediction, it just sounds like a magic 8 ball. But underneath all of that, you've got to have, um, data that effectively has positive predictive value.
Hmm.
It's got to be a big enough representation of data where, you can actually develop some pretty tight models, so you don't have, some unusual phenomena in the data. Um, Ideally, that data is refreshed on a fairly regular basis. In the case of Polaris, uh, trying to think, Brady. I'm not involved in the day to day on that stuff, but I can't think of an instance where a hospital or health system or a hospital based medicine provider that's on the platform doesn't give us data at least once a month. So we're constantly retraining the models to make sure there's no model drift. So
Hmm.
kind of underneath all the sexiness of the AI, there's this real competency that you have to have around data management, kind of data hygiene. Um, that if where you see models really fall down, I think is in one. My experience has been in one of two areas. You didn't think about the data the right way, and so, or you may even be trying to predict something with a data set that's just not very helpful, right? The second thing I would tell you is, and you probably have studied this in class already. And by the way, I'm not a data scientist. I understand the space enough from a business perspective, right? So I kind of lead a business that launches these companies. I don't, I'm not technical anymore. My hands are the only hands to keyboard these days is to send emails. Like I don't code anything. I don't, I'm not a developer.
No,
But
I'm not that deep. I'm just researching, you know.
well, the second area where you see kind of misses when people will develop something in a lab and then put it in the wild to production and then the models just fall down. You have to have some real discipline about how you train the models. So in our instance, or in our example, in every instance I can think of, when we get a data set, we will use 60% of it and essentially develop a model. We'll train and develop a model. And then what we'll do is of the remaining 40, we'll cut that in half. And so the next 20%, we will score the models we developed against that 20% of the data that we have not yet looked at. And so we do that for a number of reasons, but one of them is it's an honest look at how the models will perform. If you train on all the data, you run the risk of having what's called a memorization model, where it's the machine does really well against the data set it's already trained against. But then when you
Hmm.
put it in production, well, that's an ever changing data set, and so it doesn't really know how to handle that. So in our case, train on 60, develop the initial set of models, scored against that next 20% of data you have not seen. We call that a holdout, data set. So you'll typically hear it referenced as holdout and validation set. And then that gives us a chance to tighten up the models. Maybe we find that, it's 65% accurate, 70%, but we'll start to understand where the miss was. We'll retrain, update the models, right? Kind of update our belief, if you will. And then from there, we score against that last 20%. And that's where the exercise ends, right? And
Hmm.
so that's how we get a pretty good semblance of how a model is going to perform in the wild or in real life or in a commercial application. So my experience has been either the data quality is not there or the depth of the data is not there. And so the models just, it's hard to develop models that are tight as a result, or the data might have been sufficient, but you trained and developed in such a way that you kind of consumed most, if not all, of the data. And so, of course, it scores really, really well when you run it, when you take a subset of that and randomize it and run it through. But it's because the machine kind of has a some understanding of what that data looks like, or at least a part of it. But when you go to the wild, it kind of falls down. So,
Hmm.
um, those are we went to the lifeguard thing, and I just wanted to use that as an example to say, yeah, like you've got to have the data. The data's got to be there. It's got to be deep enough and wide enough, et cetera. And so I wish I could tell you, send me your pool hours, and we could build a schedule for you. But there's so much that's happening kind of beneath the surface here that
Yeah,
kind of sets the table for this.
yeah, I see what you're saying. Okay, well, maybe you want to shift gears and talk about some more conceptual stuff. Maybe you could answer some questions about, I don't know if you know anything about, but like, why might people be reluctant to use AI currently, and maybe what does the future of AI look like? I mean, obviously you guys are already implementing a lot for 15 years, but maybe like what technology are you waiting for, or what is still developing? Um,
Yeah, I think, I guess to your first question, I think it's fear of the unknown. I think that leaves a lot of room for people to imagine what might happen. I think there's an awareness. I mean, for me, I don't want to understate this, but for me, what AI is really introducing now is really just it's automation, right? What we're talking about here is machines doing things that primarily only humans have done. And anytime you have that level of disruption in an industry or in the world, there are economic kind of impacts of that, typically in the form of jobs, right? And what you'll find is over time, the economies grow because of that disruption, but there is pain, right? There is pain in the process, and so I think people are fearful of what the unknown. I think people, there's a lot of sci-fi around AI, and everything from like the Minority Report, all the way down. So that I think freaks people out. And then I think, what does this mean for me? Right? People mostly look through that lens first. What does this mean for me? And when you see these demos and you see these media reports, et cetera, you could quickly imagine a scenario where, one day um, you're no longer needed professionally because a machine, will do the work and do as good or better of a job, and won't complain, won't take a day off, won't take a sick day, won't quit, right? Like, so from an employer perspective, kind of a dream scenario, but the implications of that on society, I think, are still to be sorted out. And I think, that's probably scary for people. In terms of the future, um, there's a lot of folks out here uh, forecasting where things are going to end up. Are we going to end up with full AI or singularity or whatever? I, I think it's one of those things. I think we're further away than people realize, but maybe closer than we think too, right? So, do I expect it that we'll get there or near there in my lifetime? Probably. Um, is it going to be as what we've seen in the movies? I'm not sure. There's still a lot to unpack around. Machines can they can feel like they have emotions because they understand the sentence structure of what to say in a particular situation. But there's a depthness, I think, of human communication, of human design, of human touch, of ingenuity that I don't think you can replicate with a machine. I could be wrong. We'll see. So I think there's always going to be room for humanity to kind of do what it does uniquely and what it does best. Um, is that 5 years from now? I don't think so. Is that 10 years from now? Maybe. I mean, these advances are pretty meaningful. Um, is it 50 years from now? I think absolutely. Yeah. Maybe we're not at full AI or singularity, but probably pretty close, if not there. Some of this is also there's a lot to unpack here, but processing power, right? So quantum computing, I think, is going to play a really big role in this. And so if you can imagine the speed at which we'll be able to, well, and frankly, again, not to get too technical, but the fact that in quantum computing, everything doesn't have to be a one or a zero, right? That just creates so much space here for us to improve model development, speed. I mean, there's so many layers to this. So there's a lot still coming that we're expecting to develop. That's just going to accelerate the timeline here, which is why I'm telling you, like, is it 10 years from now or 50 years from now? I'm not sure because frankly, 50 years ago, we thought we would already be here today, right? So hard to say. Um, so yeah, I think those are. I mean, in terms of healthcare, like Chat GPT, Bard, stuff like that. Best and worst thing to ever happen to me professionally. Worst in that 648,000 people have asked me random questions about it because they know I'm in the space. But best in that I think people are finally really thinking about, wait, this is real. And what does this mean for me? What's interesting about the contrast between Microsoft and Google, and for full disclosure, I spent almost 10 years at Microsoft, as you know. Um, when Microsoft did their demo of OpenAI's capability that they put into Bing, essentially, I mean, it blew the world away, right? People were just blown away by what happened and what they saw, and so I think what you saw was a very emotional reaction to what they were witnessing, right? I would imagine it was akin to seeing the first plane take off or the first car, whatever the case might be. And then Google had their event as well, and it fell on its face. Right now, a couple things happened. One, clearly it was a hurried thing. It was a response. They admitted as much. But the real reason I think they got knocked was half the results that came back in their demo, their scripted demo for the press, were inaccurate. They were wrong. And so people that gave the perception that Bard is way behind OpenAI. Are they behind? Maybe, probably. Is it meaningful? I don't think so. I think they're a lot closer to parity than people realize. Here's why I say that. One of my favorite analysts, his name is Ben Thompson. He runs a website called Stratechery. It's a paid subscription. I gladly pay it. I love his stuff. He did a whole breakdown of this, and he and some other folks, they went back and rewatched the Microsoft announcement. And guess what, Brady? Half the results in that were wrong too. It's just nobody noticed because emotionally people were so caught up in what they were witnessing that nobody really thought to check. And so it turns out the parity in the results between OpenAI and Bard was relative to their kind of announcements was pretty close, but the perceptions were really far apart. And so I like Google's chances. To be candid with you, I bought Google stock that day because it went down, and I thought this is an overreaction. And one of the reasons I like Google's chances is not just the sheer amount of capital and resources they have, but if you think about it, they've already indexed the whole internet. The data, kind of quote unquote, the data set that you need to train on, it's what they do as a core business. And so they've got that advantage where they've already got that in house. And so I think they'll be able to close that gap pretty quickly. What does this mean for healthcare? There's a lot to think about there, but I'll say this: what I foresee happening is, imagine taking these like large language models and applying them. So if I'm a patient, do I want my doctor running my scenario through Chat GPT? Chat GPT returns a lot of really interesting things. I mean, I'm sure you've heard stories. I heard one about somebody asking about a particular topic and what are the 5 most authoritative books that someone would want to read. And so, Chat GPT spits out this amazingly well-written, very authoritative sounding kind of answer. And then when they went to research the books, none of the 5 books are real. It made it up. It's a hallucination. So I don't know if I want my doctor using ChatGPT as it exists today to diagnose me. I don't hate the idea that he might reference it, and it might, kind of like my suspect sepsis thing, where that was a very finely tuned, very narrow use case. Maybe it says something that causes him to ponder and helps me. But given the rate of hallucinations that we're seeing, that's a little scary too, right? So what I do foresee happening is, if I'm maybe the CMO of a health system, maybe I select a handful of curated or trusted data sets, and then you apply something like a large language model on top of that. And so at least I have some confidence in the data set that it was trained on so that I have a little higher confidence in the result it's going to give me. You may still have some hallucination there, but that could be easily kind of checked against the underlying data to make sure that the machine's not, going crazy here. So you could define it a little more narrowly. I foresee scenarios like that coming sooner than later because that's a lot easier to execute. That's not indexing the whole internet. That's saying we trust these 50 sources of data as it relates to, you can imagine AMA, New England Journal of Medicine, stuff like that, right? So I think as an interim step, that's probably where you're going to see people step into next. It's not an area we're going to explore, uh, frankly, because I don't think there's going to be a competitive advantage in doing that. That's not going to be there's not a big enough moat there, I think, to do something unique and distinctive. You could go first and kind of take advantage of kind of first mover advantage, maybe get share. But if it's easy to replicate, that probably won't last very long. So hopefully that
Yeah.
answers your two questions and also kind of where I think it's going.
Yeah, I think great input on that. I know we're running out of time, so I think uh I'm ready to move
I
on.
can go I could go to 2:30 if you want. If you have more questions and it's helpful, I'm happy to keep going. It's up to you.
Okay. I've got a few more.
Yeah,
Um,
I'll try to be more brief on the rest of them.
no, you're fine. So maybe I just wanted to ask about why your company is interested in the medical field specifically, just for my own interest. And then
Yeah.
maybe you could help me out with some vocab words. I know like we've got language model AI, but what types of AI do you guys specifically call yourselves and stuff like that?
Yeah, I'll start with the latter one. It's not going to be very helpful, but pretty broad. We'll do everything from NLP, NLG, and all the kind of prerequisites, image recognition, et cetera. We do train and untrain, so it's pretty broad. Our chief data scientist is, I think, I would say world renowned in healthcare. Considered one of the top guys out there. Google has a platform they acquired called Kaggle, Kaggle, where people go to compete for kind of accuracy, kind of get ranked, if you will. Um, Damien finally fell into the top 2%. He used to be top 1% and kind of had been there forever, but he also hasn't competed in like 4 or 5 years. So to give you a sense of like how far out there he is, he hasn't competed in 4 or 5 years and it's still in the top 2%. Um, that's I'm sure you were looking for a little more specificity, but it really has been a pretty broad use of, we've done diabetic retinopathy, which is images, understanding who's got diabetes. We did work many years ago. We produced models around West Nile virus, Zika, that helped cities understand where ideal spray patterns. So you can imagine that was a lot of different inputs there. I mean, it's all over the board. I mean, we all wear these Aura rings because we did some work with a particular university that's in partnership with Aura. I'm not allowed to give you the name, but you could probably figure it out. You could probably ask Open AI. They'll probably tell you who it was. Around who's getting sick. So like it's just really broad. To answer your other question, um, there were a number of factors that led to me getting focused on healthcare. But when I got into Microsoft, I was a technology strategist, and basically any large customer in the state of Tennessee, I got to work with. And wasn't a sales guy. I didn't have a bag. Like I was legit a technical resource. Back then, I was technical. I was a technical resource, and my job was to, as a strategist, help them understand how to use technology to accomplish their business goals. And of course, because I was working for Microsoft, the hope was that it would be Microsoft technology that would help them get there. And so I supported a lot of different industries. But around that time, um, my second daughter was born. She was a preemie, and we had all sorts of challenges with her. And she's 22 now, almost 23. Um, but it was a real struggle to understand what was going on with her, to get kind of the necessary information that we wanted as parents to just have a sense for what was going on. And we just found we knew we were in a very blessed position to have really good health insurance and to have a reasonably good income where we could kind of navigate this without worrying about the financial considerations. And yet it was still and very flexible in work as well, right? You could take off when I needed to, go to appointments, et cetera. And yet it was still really difficult. And so I just at that point, started thinking a lot about, hey, can you use kind of your gift here around technology to help improve this for people? And right around that time, Microsoft wanted to get serious about healthcare. And being that I was here in Nashville and there's so much healthcare here, they just said, hey, we want to stand up a healthcare vertical. Um, we think it makes all the sense in the world, for you to be in it if you're interested in doing that. And we were already dealing with Kimmy's kind of situation, and so it was just perfect timing. And so I said, absolutely, sign me up. And I really just committed my professional life, at least, to being a part of the solution. I mean, I applaud you for wanting to be a clinician. I think it's one of the hardest jobs in the world. We keep ratcheting up how hard that is. We keep putting more and more and more requirements on our clinicians, regulatory, financial. And oh, by the way, you need to engage with, even though you have to spend half your time documenting stuff, the patient needs to feel like you're only focused on that. Like, it's a really hard job. And so, and I think that's part of why you're seeing the burnout, and also because of the expense of it and how long it takes to kind of become kind of an earner, if you will. You're seeing fewer people go into the space. And so if you kind of play that all the way out, that's kind of scary 10, 20 years from now. And so for me, my God, we better be working on ways to make this easier, more attractive, more efficient. Because Brady, by the time you get your MD behind your name, the ratio of clinicians to patients might have doubled by then. And so we're going to have to figure out how to help make you more efficient. And so that's just kind of where our focus is. So if you notice, the more recent things we've developed have been around productivity, around scheduling, around finding those clinicians that are hard to find, et cetera, kind of very mission driven and focused that way.
Awesome.
Our ambition, if you want, I could send you, we spent a couple of days, when we started this company, we spent a couple of days thinking about mission, vision, values, what's our preferred future, et cetera. And high level are, whereas you'll see people say we want to be the largest or the best or the whatever, we very intentionally set our goal as being the most admired company, advancing business with artificial intelligence. And admired, it doesn't mean biggest or most expensive or cheapest or most famous. It means that relates a lot to how you feel working with us. We wanted to be very thoughtful about our motivation in a partnership to make sure it was always about you, the partner, and not about us. And if we had a good partner, guess what? You felt the same way. You were thinking about us and not you. And so the partnerships really, really work. And so we've had some tremendous partnerships that have birthed, these companies and more. That's my why. That's how I got into healthcare, and that's why I'm still in healthcare.
Awesome. It's interesting you mentioned burnout. I did my last interview project with a doctor who was doing research on burnout and how they could it wasn't an AI process, but it was how they could predict how a student would be burnout wise and if they would be a good student. And they were developing a test that they could take that would measure emotional intelligence. And that's usually the key factor, is what they had found. But yeah, I find that really interesting. I didn't know you guys did image processing as well, which is really neat. So
yeah, we did a more recent example of that. Sorry, something's been bothering my eye, which is why I keep rubbing my eye. But I think they're on our website. We did this. We did a project for a company called My Wound Doctor. We don't normally do project-based work. We look to build companies. If there's someone that wants us to do project-based work, at this point we just say no. We're just too busy launching companies. But in the 5-year journey at Switchpoint, we said yes on occasion. And that in our world, that typically is a cash and equity deal. We want to align incentives, or we want to have aligned incentives with our partner. And so rather than take cash today, I'd rather take some cash and bet that the company will be successful on the equity. And sometimes that's a royalty or a rev share, but it's most often equity. And so anyway, we did a proof of concept with a company that's recently rebranded. It was My Wound Doctor, and now it's called Esperata Health, and they do wound management. And so usually wound managements are really expensive, very very specialized kind of thing. This is for kind of not that level of wound, but kind of just a step beneath it. And there's no real solution in that space. And so what they did was they created some proprietary protocols around addressing wounds. And so literally you could snap a picture. And actually, I did this. My wife cut herself on the back of her arm, and it was taking a while to heal. And so I took a picture and I sent it to them, and they sure enough, told us what to do. But the challenge is the way the model works today, or worked at the time, was there was a linear relationship between number of clinicians they had to hire and how much volume they could have. So in other words, there was a ratio 1 to 50, 1 to 100. I don't remember the real ratio, maybe 1 to 200. And so, as we know, clinicians are expensive and hard to recruit. And so the question became, did they have enough data where we knew what the protocols that were assigned for each wound or image was, and what the outcome was, right? How long did it take for the patient to heal? And so what we ended up building was a solution that would look at, so when the picture comes in, the machine would actually look at it. And that's a little bit harder than it sounds. And I'm going to probably say stuff that is more technical than I can, but like, it's not just, it's the size of the wound, it's where it's located, it's the depth, it's the scarring around it. It's I think it's called abrasion maybe around the wound. Like there's all these, it's the depth of the wound. There are a lot of factors actually that go into what's the best pathway for a given patient. So that was a pretty interesting project, because as you imagine, you see wounds of all sorts. Your dad and I have a mutual friend who told us a story. I think it was him. It was either him or a friend. I think it was him that did it, but he was backing up and didn't realize that he was that close to the car, and the back of his calf touched the muffler, which was of course just scalding hot. And so he had this ring that was of course in scabbing and the whole nine. And so took a picture and ran it through, and then we sent him a package. And so that was a more recent example of some heavy imaging stuff that we've done. We also did, I'll say this and then I'll stop. We built a platform called Scout with a partner, Montecito Medical. They're the largest private acquirer of medical office buildings in the country. So they buy buildings from doctors and lease them back to them. And they very successful, like 17, 18 years into their journey. And the question became, hey, could we use their data to help them understand what buildings are ideal, where to spend their energy? In fact, we even got to a point where we built a solution for them that of all the buildings that were out there that would be attractive to them, which ones are they most likely to actually win, like in terms of like closing the deal. So a lot of AI in here, but ultimately, they wanted what they called trophy buildings. So there are some buildings that if it meets all your criteria, just looking at it, you just know it's an attractive building. It looks like the kind of building you'd want to own. And so rather than having to profile all those, we essentially train on all the buildings they bought to date that they consider trophy buildings. When they find buildings that even they bid on but don't necessarily win, you label it, if it's a trophy building, you label it as a trophy building. And then literally the machine, using Google Earth and images, it knows the address to every MOB in the country. If the photo is high enough quality and resolution from Google, the machine has been trained on what you consider to be the look and feel, kind of the aesthetic, which is obviously subjective, of a trophy building, and will actually go through and then auto label the ones that you haven't seen before. And so if you can imagine, for them as an acquirer of medical office buildings, now you go through and say, show me all the ones that meet all of my criteria and trophy buildings, which is pretty interesting little use case. They ended up buying us out of our part of that JV last year, so it was very successful for both of us. But another kind of that was a lot more than imaging, but there was an imaging component. So since you mentioned that, I thought I'd share
Yeah,
that story.
super cool. Well, that's it for me.
Okay.
Yeah,
Well,
I really appreciate talking to you.
if you think, yeah, gladly. If you think of any questions you didn't remember to ask, or if something I said triggers another set of questions, just drop me a line, and happy to, or text me. We can, you can call me, or we can do another Zoom, or whatever you want to do. But whatever's helpful, just let me know.
Yeah,
Think
I
the
really appreciate it.
think
It's
the
really
world of
fun.
your dad, man.
Yeah, it's really fun talking to you, and I like your business. Sounds super interesting. I'm really interested in the medical field right now and new technologies. So it's always fun to talk to someone new, especially if I can incorporate it into my classes. So it's awesome.
You got it, man. Anything I could do to help? Well, good luck with the assignment, and let me know how things are going.
Yeah, thank you.
All right, good to see you, Brian.